So in our last video, we discussed ions and isotopes. Today we're going to talk about bonding and the way that different atoms join together to make compounds. So we are going to first define the word compounds. Compounds are two or more different elements that are chemically combined or bonded together. There's an actual bond that is formed in this example between this hydrogen and this oxygen. They are chemically connected. There's a bond that's created here, and that's denoted by the black line. So we need two or more different elements, all right? So that means that this is a compound because I see hydrogen and I see oxygen. This is a compound because I see oxygen and carbon. And this two-lined thing right here, that means that it is double bonded. Here, ammonia is a compound because it has N and H. And lastly, methane is also a compound because it has C and H. So when two or more elements are chemically combined together, that is when we have a compound. And we're going to talk today about how those compounds are created. So one way that those bonds are created is through ionic bonds. And you should recognize this word ions. We talked about it, and you should be able to remind yourself that an ion is when an electron is gained or an electron is lost. Now remember, when an electron is gained, that makes a negative ion, and we call that an anion. And when an electron is lost, that becomes positively charged, so we call that a cation. All right, so in ionic bonds, an ion has to be created. That's the most important thing. Here, sodium is creating a cation because it is losing this electron. That in an ionic bond, when we have these atoms that have become ions, they then have charges to them. Here, like we're saying before, if you lose an electron, you're positive. If you gain one, you're negative. And an ionic bond, that occurs when ions with opposite charges are attracted. You guys are probably too young to remember the great Paula Abdul song that said, opposites attract, right? A positive and a negative go together. And so what happens is when we have a positive cation, here we have our cation. It's positively charged. It is going to be attracted to an anion of a negative charge. And when they are attracted to each other, this creates an ionic bond. Now, we looked at the periodic table, and I'm going to draw a super great picture of it right here, right now. Amazing. We said in general that everything on this side of the periodic table, with the exception, of course, hydrogen, is a metal. And we said that metals, what? Do they tend to gain or to lose electrons? Hopefully you said they tend to lose electrons. When they lose electrons, they form cations. Over here on the other side, where we have our nonmetals, these tend to gain electrons, and they become anions. So, ionic bonds form, as we can see, between the metallics, so a metal, and a nonmetal. In order for an ionic bond to occur, you must have a metal that is bonding with a nonmetal. A metal and a metal bonding together is not an ionic bond. That is a metallic bond. You must have a metal and a nonmetal. So here, let's look at this example. We can see here that sodium, right, if we look at our periodic table, we know it's a metal, so we should know that by looking at our periodic table. But when we look at this Bohr model, we can see that this electron here is extra. There is one valence electron here. And so what is going to happen is that this sodium atom is going to release this electron or lose this electron. And when that happens, that creates sodium positively charged. And this electron then will come over here to our chlorine, which has 7 electrons in its outer shell, and that will make chlorine negatively charged. And then this positive and negative charge will be attracted to each other and form an ionic bond of NaCl, which is sodium chloride, which is salt. Here's another example. Here, magnesium chloride has 2 valence electrons. Over here, each of our chlorines can only fit 1 more. So when I move this 1 electron over here, my chlorine now has a full outer energy shell, and this extra electron will not be added to this chlorine. In fact, what will happen is this electron will move and find another chlorine to become attracted to. So my magnesium is positively charged, but since I lost 2 electrons, I have a +2 charge. Now I have a chlorine here. I lost 1 electron, but I have a second chlorine also. So it lost 1 electron. So we are going to say that this is MgClCl. And we're going to learn that when we have doubles like this, we can write a subscript. So this will become MgCl2, or magnesium chloride. And you should notice that this 2 right here is going to balance with these 2 negative charges over here. So hopefully ionic bonds make some sense. Covalent bonds are different. In an ionic bond, electrons are given up or gained to create ions. In a covalent bond, electrons are shared between atoms. Only the outermost energy shells or electrons in the energy shells are shared. Remember, we call these valence electrons, and covalent bonds occur between 2 nonmetals. So if we're looking at a super great picture of our periodic table again, we are talking about the nonmetals, which are over here. And remember, hydrogen is also a nonmetal. That's why we see it right here. So in this example, this blue represents the electrons that are from the carbon. And we know that carbon has 4 valence electrons because it's in group 14. We can see that from the periodic table. And then we know that hydrogen has 1 valence electron because it's in group 1. And in order to get a full outer shell, these are going to share electrons. Let me ask you a question. Why does hydrogen only have 2 valence electrons? I thought we needed 8 valence electrons. So hopefully you remembered that our first energy level has 2, our second has 8, our third has 18, but we really aggregate as 8. So this hydrogen only has 2 spots in its valence electron shell to be able to fill, and that is why it has 2 and not 8. So the number of covalent bonds that an atom can form is equal to the number of atoms needed to fill the outermost shell. So here we have fluorine. Fluorine is a group 17 element, which means it has 7 valence electrons. That means that each one of these fluorine atoms need 1 extra electron added in order to fill their outer shell. That means they can each create 1 bond. They each have 1 bond. Here is that bond. If we look, for example, at a element from the oxygen group, things in the oxygen group, which is group 16, have 6 valence electrons. So if I draw my Lewis dot of oxygen, I know that I have 6 valence electrons here. Because I have 6 valence electrons, I know that I need an electron in this spot and in this spot. Since I need 2 electrons, this oxygen will form 2 bonds. So we can bring something in to that bond, like hydrogen. And hydrogen, as we know, has its one valence electron. And these valence electrons can then be shared. So this hydrogen is missing an electron here and here. And we can then share these electrons. And when we share them, we create a bond. And that is what covalent bonding is. So here we're going to look at an example. These are two hydrogen atoms together. And the first thing we need to do is determine how many bonds does it make sense we're going to have. Well, this hydrogen atom has one valence electron. It needs one more. This one also has one valence electron and also needs one more. So it makes sense that this valence electron will get shared here and this valence electron will be shared here. If we make this our red hydrogen and this our blue hydrogen, we're then going to have hydrogens over here that share these electrons. Whoops, it's a pretty terrible circle. Let me fix that by just using this giant part of my marker, because the valence electrons need to go through both of these atoms. So that's what we are going to illustrate here. Get another example. Here's carbon, and for hydrogen atoms, we know that this carbon, we know that this carbon has 4 valence electrons, which means that it can create 4 bonds. So we would expect each of those carbon, or for that one carbon to have 4 bonds. These hydrogens have 1 valence electron, and they need 1 more valence electron. So each one of these hydrogens will create 4 bonds. So what is going to happen is if I make all my hydrogens blue, this electron right here is going to be shared here. This electron is going to be shared here. This one will be shared here, and this one here. Great. Now our carbon has a full outer shell, but our hydrogens do not. So carbon returns the favor and allows for these electrons to be shared with our hydrogen atom. What this ends up looking like is a crazy Mickey Mouse pool at first, and then eventually it looks like all of these atoms join together, sharing these electrons and creating a bond. So if you were going to rate this, this would be a carbon bonded to 4 hydrogens. And that is what covalent bonding is. Remember, covalent happens between 2 non-metals. And if we have 2 metals that bond together, that creates a metallic bond. We're not going to talk about the mechanism in which that occurs like we did about for ionic and covalent, but you need to know that 2 metallic bonds together, 2 metals together create a metallic bond. The next thing we're going to briefly talk about is chemical formulas. You've seen me write a couple of these already in this presentation tonight, but I would like to give you a formal definition and understanding of what chemical formulas are. So chemical formulas are the language that help tell us how many atoms there are and which elements are bonded together. So here we have an H2. This 2, which we call a subscript, tells me I have 2 hydrogen atoms, as are pictured here in the blue. This oxygen, just so you know, there's always a 1 there. We just sometimes don't write it, right? It's like how in math, 4 to the first power is equal to 4, right? But we don't write the 1 there. We just know that this is a 4, right? So it's kind of the same idea. So we have 1 oxygen here, and when we join them together to make a compound, we have 2 hydrogens bonded with 1 oxygen. Let's talk a little bit about what that means. We have subscripts. This is not a great representation of what a subscript looks like. Let's go ahead and get a new one up there. It would be something like O2 or CO2 or CH4. All of those small numbers at the end are called subscripts. And that tells you how many of each atom of that element are bonded together. And like I said, if there's only one atom of that element present, we do not write the 1. We assume that that 1 is there. So let's go ahead and talk about how many atoms are in these compounds, and whether or not they're an ionic or a covalent bond. So in this first one, I see 2 different elements. I have hydrogen and I have oxygen. This 2 applies only to my hydrogen, so I have 2 hydrogen atoms, and there is 1 oxygen atom. And hydrogen is nonmetal, and oxygen is a nonmetal, so this makes a covalent bond. Let's look at another example. I see a C, H, and an O. I see a 6 here, which applies to my C, so I see 6 carbons. I see 12 hydrogens. I see 6 oxygens. All 3 of these elements are nonmetals. And since all 3 of them are nonmetals, I know that this forms a covalent bond. I would like you to try the next 2 on your own and then press resume when you're ready. Okay, I want to point out a couple things. First of all, should have gotten that there were 2 bromines here and that both bromines are nonmetal, and so it creates a covalent bond. As a quick reminder, these smaller letters, remember, that is a part of our capital letter. So this is sodium, that is 1 element. This is chlorine, that is another element. So we have 1 sodium, we have 1 chlorine. Sodium is a metal, chlorine is a nonmetal, so here we have an ionic bond. All right, go ahead and pause the video and go ahead and figure these ones out too. All right, hopefully you realize that calcium, there's 1 of them, it is a metal. There's 1 oxygen, it is a nonmetal. And remember, when we have a metal and a nonmetal, we have ionic bonding. We also have calcium bromide. Calcium is a metal, we have 1 of them. Bromine is a nonmetal, there are 2 of them. Since we have a metal and a nonmetal, we once again have an ionic bond. Now this one is a little bit more confusing, so I want to make sure we talk about it. You can see here this parentheses, right? And this 3. We distribute this 3 to the elements inside of the parentheses. We do not distribute this to the aluminum. So when I write this out, I have 2 aluminums. I distribute that 3 to my sulfur, so I have 3 of those. And I distribute that 3 to my 4 oxygens, so I actually have 12 of those. Aluminum is a metal, sulfur and oxygen are nonmetals, and so this is also an ionic bond. So we're going to go ahead and do some practice. Please pause the video at this time and resume it when you're ready to check your answers. So these are our correct answers for these set of problems. Please contact me if you have any questions. We're going to go ahead and do some practice problems now about the way that electrons move in ionic bonds. So I'm going to walk through a couple examples with you. In this first one, we're going to join together potassium and fluorine. So potassium, that symbol is K. Fluorine, my symbol is an F. And I'm going to over here draw those Lewis dot structures. Potassium is in the first group, so I know that it's going to have 1 valence electron. Fluorine is in, I'm going to use fluorine a different color. Fluorine is in group 17, so it has 7 valence electrons. So what is going to happen is that this electron is going to move over here. When that happens, that will create a potassium that has a positive charge and a fluorine that has a negative charge. and those will combine together to make potassium fluoride. So over here, I'm going to write in my superscript, I'm going to write a plus with potassium and a minus with fluorine. And then I do not need to write the ones in front because remember, our ones are assumed. So we're going to look at another example. This one is magnesium and iodine. So magnesium is Mg, iodine is I, and I'm going to go ahead and draw the Lewis dot structures. Magnesium is in group 2, so it has 2 valence electrons. And then iodine is in group 17, so it has 7 valence electrons. And so what that means is that this blue valence electron will leave this magnesium, and that will give me this iodine, which has a full shell. So I will have a negatively charged iodine, but there is still an extra magnesium electron that needs to go somewhere. And what happens is that we have a second iodine that still has 7 valence electrons. And what happens here is that this valence, oops, that's supposed to be blue. This valence electron comes in here and creates another negatively charged negatively charged iodine ion. Now, each one of these iodines has a -1 charge. My magnesium, it didn't just lose 1 electron, it lost 2. So it is a +2 charge. So really what I have is Mg, I. And remember, we learned that really the right way to write this is Mg, I subscript 2. That is our answer and what we need to put up here. So I'm going to put a +2 in my magnesium, put a -1 in front of my iodine, or top of my iodine, and I'm going to put a 2 in front because I need 2 of those.